as most of you probably know, since you joined the webinar, but we're going to cover briefly the basics. Glare is an unwanted reflection of the sun's rays caused by a reflective surface. It doesn't have to be limited to only photovoltaic installations, but this is what we are going to focus on today. And it is defined as a continuous source of bright light, which is encountered by static or slow-moving receptors. That's the difference between glare and glint, which you might also have heard about before, which is defined as a momentary flash of bright light, and this is witnessed by fast-moving receptors, which we can mention here could be cars or trains or airplanes. So these are the two definitions that we will be using today. Briefly introducing some selected regulations for different countries. You can see them here. You can also go back to this slide when you go and revise the recording from the webinar. But just to mention some of them, there are regulations regarding the intensity. There are regulations regarding the duration of glare. For example, in Germany, the limit for glare duration that cannot be exceeded is 30 minutes per day and 30 hours per year. Some similar limits in Switzerland. And there is also a limit. It also depends how you should be assessing glare depending on the size of the installations and the distance from the installations. So it's very important that you check the regulations when creating a glare assessment. Just a little bit more in detail, as I mentioned, just to focus on the specific requirements in Germany as an example. They do have the previously mentioned limits, 30 minutes per day, 30 hours per year. They additionally specify some more technical regulations of how to calculate this reflection. They mention, just before we go into that for traffic, even shorter duration can be dangerous for the users of the land transportation infrastructure. So this is something to have in mind, that perhaps all glare should be avoided close to roads or train railways, or airports. And the assumptions that they specify in the calculation is to treat the sun as a point source emitter, and the reflector should be a perfect mirror. These settings can also be set in, of course, in windPRO. The sun is emitting light from dawn to dusk. We should not be focusing on the weather conditions. It is assumed to always be the direct sunlight is assumed to always be visible. And there is a limitation on whether you should be considering the glare or not. And if the direction of the reflected glare from the reflective surface is within 10 degrees from the sun direction, this glare can also be disregarded. This is quite important because in many cases, glare does come from the sun that is very low on the horizon. And if the direction of the sun and the direction of the reflection are within these 10 degrees, this can be disregarded. A brief introduction, reason to use the glare module windPRO, also with the enhancement, as Olga mentioned, of including the visibility calculations, is we usually start with a plan for a PV plant to be placed close to residential areas or roads and roads. And then we can use the glare module to assess the influence of glare. But starting from 4.2, you can include the terrain and possible obstacles, such as forests, buildings, hedges, as one of the mitigation technique for glare. And this way you can get reliable results that are considering the abstractions, which will increase the social acceptance of the project. You can now show how glare is reduced thanks to introducing, for example, hedges between the PV plant and the receptor. And here, the two visibility calculations that we have included. And first of them is the calculation if the PV panels are visible from the glare receptor's location. So the situation that we have here on the left, we have a receptor here, and we have a PV plant which is hidden behind a hill. And now this calculation is something that we perform in windPRO. So this sun that is hitting the surface of the PV panels is reflected towards the receptor, but this reflection is never reaching it because of the terrain. And here, a visualization of such a situation where we have a building, where we have a PV plant here, and when we install, not install, but probably plant a hedge here in between the buildings and the PV plant, we can avoid having that reflection disturb the residents in the building. Here, the other type of calculation we are performing in windPRO, and this is to check if the direct irradiance is reaching the PV panel's surface. This is something that is, of course, done when you're doing AEP calculations, but now we also do it for ZVI. So if we have a terrain that is obstructing the direct irradiance reaching the PV panels, this is also accounted for. So even though without this terrain we would hit the PV panel surface and reflect it back to the receptor, we are now making sure this is not happening. And this is done by comparing the horizon line. So we have a horizon line in the point of the PV plant, and we can see the reflections here when they are happening. This graph is showing us the azimuth angle, so where the sun is from east to west, and the sun angle, so how high the sun is on the sky. Then we can compute for which sun positions we would observe glare in the location of the receptor. And these are these two areas here for two different buildings. And after that, we can plot a horizon line of the surroundings, and we can see that in fact these here, this part of the reflections that you can see here will not, in fact, be causing glare at the receptor. So we can disregard these times in our analysis. And this is something that now you can easily include using windPRO. Just to mention here, back to the first point, I just wanted to mention that this calculation is done for each of the tables, and the middle point of the tables you're defining in windPRO. We are going to go into that soon into details when we are starting our demonstration with windPRO, which we do now. So I will open our project. Most of you, I assume, are already familiar with windPRO, but just to give you a very short introduction, we have windPRO is a GIS-based tool, so we have a map here as our main window, at least in this look. And what I have already prepared is that we have a background map. This is OpenStreetMap, and I downloaded already the elevation data. So in windPRO, you can easily download elevation data for any location you're in. And here we are in Italy, and I've downloaded this data set that considers the elevation in the surroundings. And this is something that is going to be the basis of our analysis today. So I go back here, and we have a piece of land here that we would like to use for putting in PV panels. Just another small explanation here. I have divided all of the things that I'm going to put on the map into layers, and that's why I can activate and deactivate this elevation data And the same goes for any other object. I have prepared a layer for the solar PV. So if I activate this layer now, I can put the solar PV object here. And that's what we are going to do. So here in this piece of land, we are going to place a PV plant. And this is very easy when you use the solar PV object in windPRO, which you can find here, this yellow rectangle. You can select it and place it on the map close to where you want to have your PV plant installed. And what you can do in windPRO is you can digitize the plant manually. So that's what I'm going to do. I'm just going to draw the area of the PV area on the map. But you can also import it from a shapefile. That is another possibility. So now with this, you can see that I can start digitizing the solar PV area. I'm going to put it here in the available land. Something like this. And this way we have a PV plant. We can also modify it. So now, for example, if I think, okay, this is a little bit too big, I can easily move these points around. Perfect. And once I started digitizing it, you could see that this window popped open. So we have now a status window in which you can select the settings of your PV plant. You can select, of course, what is the configuration of the table, so how many PV panels you have in one table, and you can select the table angle. And we can work with fixed tilt PV plants. We can work with tracking PV plants, and the tracking that we are offering in windPRO is one-axis tracking. And we can also work with east-west PV panels. For the sake of this exercise here today, we are going to keep it as fixed tilt. And windPRO automatically suggests the best fixed tilt, or the tilt for the location. So we are going to keep this. It's going to be a fixed tilt PV plant facing south, and we have a pitch of 5 meters. So the distance between the tables is 5 meters. And I'm just going to say that I want to update the selected area, which will automatically now fit my PV panels inside the area that I digitized. And once we have this done, this is the input information we will need for our glare calculation. So then the location of the PV plant, the PV tables is going to be the important information when calculating glare. And the next step that we need to do, I will exit the edit mode, meaning I will no longer be able to easily modify it, but this is necessary for me to include the next points. And the next points is to define where is it that I want to investigate if there is any glare disturbances. And this I will be able to do by entering a object that we call shadow/glare receptor. And this you also need to place on the map in the location that you're interested in analyzing. And for this today's calculation, I've selected a place here, this building that I want to see if it's going to be disturbed by the glare. You can see it's very close from the PV area. And I will place the first building here. We need to select that this is not going to be used for shadow calculation. This is for the ones that of you that are doing environmental assessment for wind and solar at the same time. This is also quite a good feature because you can select this receptor to be both used for shadow and glare calculations, and the settings of the location and the height above the ground, all of this is going to be considered in both calculations. So this is something that perhaps could be useful for you. In this case, since we are focusing on glare, I'm just going to say that this is not used for shadow, but it is used for glare calculations. I will specify the height above the ground to be 2 meters. And here you can specify in which direction the receptor is facing. And you can also specify the field of view. Field of view, I did not explain here in our presentation today. We do explain it pretty well, or well, in our manual. You're welcome to have a look. Just briefly mentioning it here, it's you can specify, if you specify the direction, then you can specify the field of view. So how many degrees should we be considering as being problematic for the if the reflection comes from that direction. And this is something that in some regulations is specified. For example, I believe in Germany, if you are talking about assessing glare near roads, you assume the field of view of the driver to be 60 degrees. So you can then specify this to be 60 degrees, and reflections coming from outside of this 60 degrees will not be considered in your calculated glare. For this, since it's a building and we can assume that it is a window, we can also say that we have this building's window facing the PV plant. We can say that the degrees from south will be 90 degrees, and the field of view, we will assume the whole field of view of the window, so 180 degrees. Here in the position tab, you can then specify a description. For simplicity, I'm just going to call this building 1. And you can select if you want to use the label on the map. That will perhaps make it, I mean, it will definitely make it easier to identify the receptor on the map. And I'm going to say that I want to label this receptor on the map with the description. And you can specify another color. We'll go for blue with the buildings, and this way we have the first receptor defined. So you can see that now we have a receptor. We can see the field of view here. So we are only going to be considering reflections coming from the direction within this field of view of 180 degrees. If the reflection came from this direction, it would not be considered. So for this analysis, I will also like to include one more building receptor here and here. And this I will do by cloning the object and placing it here. I can double click, open it, check the settings in this building. I will keep the same settings, and the position, I will just update description to be building 2. And finally, I will place one more building here in the bottom. What I'm doing now, yes, that's something also interesting, because here I have now defined the field of view to be 180, but in this case, I will say that the buildings are not facing west, so the windows are not facing west, but in fact they will be facing north, so facing the PV plant, or maybe even in this direction. And then I will consider that this is the window that I am interested in. And I double click to open, and again, I will say then that in the description that this is building 3. So now we have our solar PV plant and our buildings defined. And we could perform the first glare calculation. And before we do that, I have prepared more receptors that will analyze the glare alongside this motorway. That's quite an important thing here. So we have a motorway passing very close to our PV plant, and we need to assess if there is glare coming towards these. And for that, I have prepared already 7 receptors. So I have 7 receptors along the motorway, and I'll just open one of them so that we can see the properties. In here, I said that the height above the ground is 1 meter, more realistic for the case of cars passing by. And the field of view, in this case, is 360 degrees. So I am interested in catching all of the glare, regardless of from which direction it comes. This could be changed. Of course, you can specify then a field of view of, for example, 60 degrees, and then specify two receptors going both ways, because here, of course, we are interested in disturbances both for the drivers coming from the north and the drivers coming from the south. But for simplicity, I just said that I'm interested in all the reflections reaching the receptor from all directions. And yes, this is the setup of the receptor for the motorway. Perfect. And this way, I have the first, I am ready to perform the first calculation. And this is done by selecting in the solar tab in the top. We have the modules that are related to our solar calculations, and one of them is glare. So here you can select glare, which will open a window where you can specify different settings. And the default settings are these. I will briefly go through them, but if you have more questions or you are curious about the specific setting, you can, of course, visit our manual. You can also ask a question, but in here we have two things you can calculate. You can include the beam spread. This is something to say that the reflection is not ideal. So the reflection in reality is never going to be a specific ray hitting reflected from the PV array. In fact, it will, so the incoming ray of sun is going to be scattered over a angle, and this is what you can specify in here by saying that you want to include it. You can also select to include intensity of glare. This is something that we for now only offer in the result to file, so you can see for each time step where you have glare, you can see what is the intensity of the reflection. We are working on preparing more reports regarding this, but for now it's available in the result to file. And then we have some of the advanced settings. You can set distance limits. You can also set, these two settings are related to the calculation, so you can set the grid resolution. I will not go into details here, but the finer the grid resolution, the more precise is the calculation. However, the problem is that then, of course, it takes more time. This is the grid resolution we settled on, and it gives very precise results. Then you can say what are the time steps for the calculation. That by default is 1 minute, and it's something that we also recommend keeping. But then we have this setting here saying that you can disregard reflections coming from the direction from the sun within a certain degrees. This is the setting that the German market requires. In our case, the default is set to 0. Of course, you can change it. We are going to calculate more or less the worst case scenario here. So we are going to keep it to 0. Then we have another tab with panel characteristics. Here you can specify what kind of panel are you using, and depending on that, the scatter angle will be set differently. Again, we are not going to go into details here. What's interesting for us today is going to be setting up which receptors are included in the calculation. By default, we include all the receptors in the visible layers, and that's what we are going to stick with in the first calculation, and also which PV objects are included in the calculation. And finally, we have the ZVI tab. This is the new tab in windPRO 4.2. And here you can select if you would like to include the PV visibility calculation. So if the receptor can see the PV plant, or the sun visibility calculation, whether the PV plant, if the direct irradiance is in fact reaching the PV plant. And for the first calculation, I'm just going to disable these two. So it's going to be a calculation without the visibility. And this way, we are going to get our first report. Just a moment. Yes. And that gave us our first report. I am just gonna rename it so that we know that this is a calculation without ZVI. And we can have a brief look at the results. Not this, preview. Yes. So these are our results from the first calculation. You can see here which of the PV panels are causing reflections, and this is to all receptors. And then you can see here first a definition of which of the solar areas are used, what is the size, how many panels, and this, the settings of how the PV panels are placed. After that, the locations of the glare receptors, and the most interesting part in this page, the calculation results, showing us how many hours of reflection we can expect at the receptors. And you can see here we do not have any glare in the motorway 1 receptor, but we have quite a significant amount of hours of glare in the rest of them. And the same goes for building 1 and building 2. Building 3, which is located here south, which we included also in the analysis, is not receiving any glare regardless of whether the terrain is or is not included. So we do have a problem with exceeding the regulations in all of them. We would like to avoid any glare at the motorway, and we would like to limit the glare from in building 1 and building 2. To be within limits. And in that case, we are going to focus on 30 hours per year and 30 minutes per day, just for our analysis. Then we have here in the reports some more information. We provide these graphs that you could recognize from the presentation with the azimuth angle and the sun angle, and we are showing for which sun locations you can expect glare. It is a little bit easier to understand if you look at the other. So the other graph we have for motorway 3, for the receptor motorway 3, you can then see for which times during the day you can expect to see glare. And that's included here in the report. And you can find a similar graph for all of the receptors. I am going to save this in the desktop for later so that I can briefly compare it with our next calculation. Because in our next calculation, we are going to include the ZVI. So now I'm going to go again into glare, go to the receptors. We have all of them selected, PV objects. The PV object is selected, and now I include the ZVI in the calculation. So I press OK to this, and the calculation will start. It's going to take a moment because now, since our first calculation was without considering the obstacles, this one is a little bit more heavy. If you worked with our glare module before and you worked with tracking PV panels, you can also, you know that if we are talking about tracking, we also usually have way longer times for calculation. But in a moment, we are going to have the results ready. Meantime, I can open this one for later. Yes. And now the calculation is done. And we can again, I will rename it again, that this calculation is with ZVI. And I will say that I want to see the report. Yes. So now, again, the same setup, and we can have a look at the results. And you can see that including ZVI significantly reduced our glare. So now we have less glare at the motorway. We are only experiencing it in one of the receptors, and it's the receptor motorway 3, which has here C in the legend. So this one. And then we are still left with a significant amount of glare in building 1 and building 2. So these are the two things that we could focus on reducing. And yes, I am going to now go into the other feature you can work with in windPRO. And now, because it's not only terrain which you should be considering which you can be considering in the calculation, but it's also the obstacles. So you can select to include an obstacle which then will cover or will prevent glare from the PV panels. And in this case, we are suggesting, or I will be suggesting, to include a hedge around the PV, the motorway. I've prepared these obstacles. It's just a very it's yeah, I will just open this obstacle if I can. Ah, yes, it's here. I know it's already there. I Sorry for that. I'll just go here. No, what is happening? Okay, we'll go here. Yes. So here we have the fences on the motorway, and you can see it here. And I've included that already. So now we can prepare a calculation with the obstacles included. And if we open the glare module again, now I can select to include obstacles to include the ZVI, but you can also include obstacles that I've put on the map. I will just cancel here because another thing I've included I didn't tell you is this. So I've prepared these hedges which are 2 meters high, and then I've prepared this hedge that has let me open it. It has 8 meters. I will reduce it to 4 meters for now, and then we can see the difference briefly in the next calculation. So I can go into glare again, and then I can select the ZVI option. And now I want to include the obstacles. You can also include area objects, but for now, I haven't included anything. Area objects could be, for example, something like forest heights. If you have a forest in between, we do not have any forest here in between, but we can include these kind of obstacles to simulate hedges. And with this, I will also start this calculation. I have here selected, sorry, I need to cancel again because I didn't activate the motorway, the motorway receptors here around. So I will go into it again, and I will go into receptors. Now we have all 10 receptors selected, and we have the ZVI again with obstacles. And I press OK to this. And I have another calculation, this time considering the obstacles. And I would expect, in this case, that I can avoid glare on the motorway altogether, and also reduce the glare in the buildings. But let's see. Yes. I can see that we have many questions here in the chat, which I will answer Yes. Perfect. So if I have a look now, I will just focus on the main results. As you can remember, now we also have a list of obstacles. I have the same name for all the hedges here around the motorway, so that's why this. But then I also have another name and the height of the obstacle specified in here. And now we can see we do not have any more glare at the motorway receptors, so we are good to go. But we are still left with quite some time of glare in building 1, and we reduced the glare in building 2 to acceptable levels. So in that case, setting it to 4 meters didn't work. And that's why we can do another calculation in which I will set it to 8 meters. And since we already are sure about no glare effect in the motorway, I will now make the calculation in glare without these receptors. So I will just say that instead of selecting all of them, I will focus on building 1 and building 2. Building 3 didn't receive glare from the start. And then again, say that we include the ZVI calculation and of course include the obstacles. And this is going to be our final calculation, just to make sure that we are complying with any regulations. And of course, it all depends on the local regulations, which is crucial to check. But now you can see that we do not have any PV panels causing glare, and also we do not see any glare in the calculation results in both building 1 and building 2 by installing quite a tall hedge, yes, of 8 meters. Of course, it will depend on the specific case. So that was our windPRO demo. And I will jump back to our presentation because we have few slides left and the Q&A session. So yes, just a teaser. We do have a solar PV course coming up. It's November 18th, and it's going to be in 2 sessions. One session is going to focus on the AAP calculations from solar PV, and there is another session focusing on the photomontage glare calculation. So you will be able to get more in-depth and hands-on experience with the glare module as well by joining the course on November 18th. And Olga is going to paste the link in the chat, so you will be able to sign up if you are interested. And that brings us to Q&A, and I can see there are some questions in the chat. I can see there, Matei asked if I could do the example with a shapefile, but I missed it when you asked for it. But I can definitely, if you send me an email, I can also show it to you, or we can have a short discussion. And then we have to do.
That's quite a long question, Marta. You can just skip it,
exactly.
And below I wrote a short summary.
Perfect. Wait. I hope now we use. And where is this short summary? Does the windPRO glare assessment report also indicate if the glare is harmful to human vision? Yes, exactly. I see. That's a very good question. So we have the intensity calculation in the result to file, and we have a possibility to do this kind of assessment in-house. We do not have it yet included in windPRO, but we will work on including that. If you have a specific case where you would like to do this kind of assessment, you are also, again, welcome to contact us, because we can do this kind of assessments. We have a tool outside of windPRO that can do it, but it's not yet included, but that's not for too long. And then we have a question about does the current version support direct import of PV farm design results from PVSys, PVKs, Heliosat? If not, is this functionally planned for the near future? Also, which file formats are currently supported for import? So for now, the import can be done so you can import the outline of the PV plant using a shapefile. You can also import, if you have a background map, for example, a background picture from another tool, that would then help you to align the PV panels locations with the picture that you have. So these are the two options. If you have the outline, then you can of course import the outline. We will suggest a layout, and then you can try and match the layout with a background picture. That is the possibility that we have right now. However, we are talking about and trying to find out what kind of format we can use to work with the other tools. If you have a specific suggestion, please reach out, and then we will have a look at it. But for now, the option is a shapefile. And the country-specific requirements, are they in windPRO? No, unfortunately, they are not. They are also not set in stone, since glare assessments are quite a new thing available, or it's quite a new requirement, or maybe not new, but it's getting more and more attention, and they are not included in windPRO. We do summarize some of them that we know as of now in the manual, but there's setting up the specific settings is for now left to the user. So we can provide you with the guidance about the settings, but we do not have them coded inside windPRO. And the calculation is performed in geographical coordinate system. In your example, small PV farm was shown, but if the farm is significantly larger, the system still sufficiently accurate. Should another coordinate system be used instead? That's an interesting question. The example that I made was for a 10 megawatt PV plant, just so we are on the same page, or approximately. But I would like to say yes, but perhaps I circle back on that question and make sure that I understand it correctly with my colleagues. Then is it also possible to use a DXF file to import the PV area? Unfortunately, no. No, it's not possible. It is possible to export, but it's a good point, and it would be interesting to have that option. And then we have, how relevant is this assessment for the actual technology of PV panels? I had a client who asked the PV panels provider about the glare, and they say that the modern PV panels have no significant glare because they don't want to lose energy. Yes, I mean, of course, it depends on the type of the PV panels. And the thing is that even though some of the PV panels they do have an anti-reflecting reflecting coating, but usually what you are focusing on when doing these kind of coatings, and I mean, I'm no expert here, but you are more interested in minimizing the reflection in the time when you get most energy. So when the sun is in fact hitting the PV panels from angles close to normal, or something around that range. And even though some of the PV panels, they still have a anti-reflecting coating, they glare at low angles. So that low angles, incidence angles on the PV panel, so the angles at which the sun is hitting it, can still be quite relevant. So it's true that perhaps in the technology itself, it's not that, it's not really a big problem usually, but could be in specific cases when you have a setup where you do get glare at low angles of the sun. Also, in some cases, such as Germany, in the regulation, they do state that you should treat a PV panel as a perfect mirror. So even though some of the PV panels can mitigate the glare effect, then still the assumption in the regulation is a perfect mirror. So in that case, you have to treat it like it and then consider it. How far should reflections be considered? I didn't notice any info menu options related to this during your presentation. Yes, so it depends on the regulation. I think here here we had some information. Here in Switzerland, for example, you're saying that it's within 100 meters from a residential zone, within 50 meters from a commercial zone. In Germany, for small PV panels, less than 100 meters. For bigger, I do not have this information, unfortunately. For France, if it was a runway, it's 3 kilometers from runway and 400 meters from the touchdown zone. So it depends again. And yes, you can specify a limit of that, so you don't have to worry about it too much when you are doing the calculation in windPRO, because you can in fact specify this limit. So if you have a big PV plant and the receptor in a specific part of, or in one location, we will take care that if you say that you do not want to consider PV panels that are further away than 200 meters, we are gonna take that into account in the calculation. Yes, and then do you have any plans to separate the solar module from the glare module? We are active in environmental impact assessment. We plan to use the glare module, but it might not be our preferred option if the solar module weren't connected. For now, we do not have this kind of plans, so you can also do glare assessments, which I didn't mention here in our presentation, with 3D objects. In that way, you don't necessarily have to use the solar PV object. Problem is that it's way easier to set up a PV plant in Pro using the solar PV object, or actually it's not a problem. It's a good thing in windPRO that it's so easy. But this is something that I cannot make that kind of decision, but also I don't know if we are planning this. Yes. How we manage airport runway nearby? That's another question. For now, the way we can suggest you do it is that is done again. Unfortunately, for now, with we work with only point receptors, as you can see in the presentation, and just yes, and then you can specify these points on the approach manually. So that's the option right now. But we are working on including linear receptors, and which will also include receptors for a specific flight path. Is the glare module in windPRO suitable for assessing glare impact for aviation? Yes, exactly. So for now, what you can do is specify these points on the flight path manually, but we are working on including that. And then visual. Can we import visual flight maps and GIS? We'd like to evaluate their impact on aviation vehicles at certain altitudes. That's a very interesting question. I think I would need more information about it. We are having a enhanced capability of GIS in windPRO 4.2 as well. So perhaps the maps you are specifying, you are mentioning, it is possible. I'm no expert in that, but please reach out, or we can also do that, and then we can have this discussion. And we have a last question. Do you have a recommended elevation dataset for tasks like shadow or glare? I've seen options like SRTM, ALOS Pulsar, and Copernicus DEM, but I'm unsure which is best for our needs. I would, yes. So the thing is, of course, that's again, it's a trade-off. The more accurate DEM you will use, the more accurate results you will get, and but of course the longer the calculation is going to last. So but I do suggest that for depending on the country, for some countries we do also provide a local DEM, digital elevation model, and that's one way of handling it, and this usually has a fine resolution. And these are best for the analysis with terrain included. We have two more questions. Is it possible to calculate with this module the shadow flickering by wind turbines blades on PV farms? No, this is not one of the capabilities of this module. And if you have in mind that the effect of the shadow flickering on the calculation or on the AEP calculation, so annual energy production calculation, this is in fact something we can do in the solar PV module. So you can consider that there. And you can also produce a map of, with a little bit of work, but you can produce a map of these shadings. Is there any option to do a ZVI map for PV in the same way as for wind farms? It is not an option in windPRO 4.2. We are working on including ZVI so PV ZVI in the ZVI module so that you can create a ZVI map in windPRO 4.3. Or yes, we are working on that. And I think we covered all the questions in the chat. If you still have any questions left until after the webinar, something pops to mind, you are always welcome to reach out to us and we will be happy to help.